started soon. But yeah, thank you all for being here. I mean, I guess if you're at this workshop, you're probably a bit more serious and like passionate about mobile or Android development. So it's going to be a good one. Okay. I guess I'm going to start talking about this workshop for a bit, and I'll let people go in before we get started with the actual application part. But welcome to Advanced Android. Today we'll be talking more kind of about how to do multi-threading and like concurrency and like asynchronous programming in Android. So a more advanced Android topic, but something you definitely need to learn if you want to like completely master the world of Android. Definitely more of an advanced topic, but even if you're not familiar with Android, this is still definitely applicable to you because we won't need a lot of like prior Android knowledge since everything we'll be talking about is so kind of self-encompassed basically. Okay, let me quickly start off by talking about who I am. Third time, I guess, so hope maybe this is still new for someone, but my name is Bobby Wong. I'm a 4A computer science student at the University of Waterloo. For my Android experience, I've done 3 internships in the past, and I have one planned upcoming Android internship. And I have 2 published Android apps under the Play Store, so lots of Android experience. All right, let's get right into it. No breaks today. We're going to be talking about Kotlin coroutines and Android livedata. The two tools you'll need to learn if you really want to make use of multiple threads in Android. At the end, I'll be kind of talking about a mini topic, which is about measuring views, and that'll serve as kind of like a mini warning if you want to continue like really down the line with Android developments. Okay, let's get started right away with talking about Kotlin coroutines. And I guess before I get started, let me quickly talk about what coroutines actually are and kind of why we need to use them. So basically, a Kotlin coroutine is a lightweight task that you can think of. So in Kotlin, there's a really nice feature called coroutines that lets us start up tasks super easily. And it's a really big boon to use it in Android since it makes the task of creating new tasks really easily. It'll make a lot of sense once we get into the programming section of this workshop on why we should make use of tasks and how that benefits our Android programming. But okay, to get started, let me talk about why we even need to care about threads in the first place. So basically, if you have an Android phone or basically any phone nowadays, that phone is going to have multiple cores, and those cores are capable of running like more than one thread. Obviously, it's more than likely your phone probably has 4 cores on it right now, and that's really important because each of those 4 cores is basically like a worker. If you're not making use of all 4 cores, you're probably only making use of one, and that's like 1/4 of all the total processing power you have access to. It's very simple to use only one thread and one core, and that's probably what the bulk of your Android programming has been so far. But I'll be kind of talking about today how you can make use of the other 3, and this is really important because if you only use one thread, that means that one thread is responsible for everything. And under Android, we ideally only want to keep that one thread to only handle UI changes. So think about this. Let's say you have an app that's currently running right now on one thread and you wanted to make a large API call, and that API call through the internet takes 5 whole seconds. If you make that call on the main thread, what's going to happen is for that 5 seconds the API call is running, your application won't be able to respond to any other kind of UI changes. Like if the user taps or try to exits back or open another thing, they won't be able to do that because the UI thread, that one single thread, is busy computing your API call. And actually, it's so important that actually Android Studio and Android doesn't let you make API calls on the main thread at all. That's how bad of a user experience it would be if that happened. Okay, so now that I talked about why we need to make user threads, let's get started right away with the practical section of today. So hopefully everyone has Android Studio open and has the GitHub repository I showed earlier at the top of the chat ready to go. Okay, I have this little simple program set up that will show off kind of what the importance of thread is and how we can use it. So this application might look complicated, but it's actually fairly simple. At the top, we have a counter and basically some code that will run every second. So you can see that this counter is counting, oh, 1,000, wow, 4 digits. You can see that the counter is counting up once every second. And basically this handler is gonna post a new task every second. every second, which will increase the counter and show it in the text view. If you're in the intermediate section, this should look very familiar, but even if you weren't, it shouldn't be a big deal, because what I have here is I have a recycler view, a list, and that list gets its data from here, which will fetch it slowly. And in this case, I have some dummy data. It's just a few simple entries, but I purposely put in a thread.sleep for 5 whole seconds to kind of emulate a large API call. So let me actually restart the application, and hopefully that'll make it clear why multiple threading is important. So it just started up, but you might notice it's just a white screen, and it doesn't seem to be doing anything until suddenly just everything shows up. And actually, some of you are probably already aware of what's happening, but if I count, so 1, 2, 3, 4, 5. It actually takes 5 whole seconds because of this fetch that is slow before any of the other UI tasks can be computed. And that's obviously very unideal. You know, the user probably just is going to think your application crashed, and if it gets any worse, the Android operating system might even show an error saying that your application is already crashed because it's gone unresponsive. So let's get started right away and talk about coroutines. Oh, before I continue, inside the build.gradle file, I've added these 3 libraries in that will make working with Kotlin coroutines a lot easier down the line. But anyways, that's just a thing to know. But okay, let's get started right away. So let's talk about what coroutines are, what their advantages are, and why we use them. So the first advantage coroutines has is that they're really lightweight and easy to use. And you'll be seeing that as I start writing down coroutines, but the steps to make a coroutine are actually really simple and not complicated at all. It's a very nice break from the days back in Java where we have to worry about kind of like async tasks and like different classes and whatnot. In Kotlin, it's so easy. Um, Coroutines are also what's called lifecycle aware. And what that means is basically, imagine you're making a data call, but the user exits out of the application before the call can finish. Because coroutines are lifecycle aware, that coroutine will stop computing because it's aware that the actual screen, the actual activity has already died. And the last point is kind of coroutines are not callback based. It's kind of hard to talk about this one, but basically working with coroutines, you don't have to worry about like callbacks and get like and fetching data sources. Getting data in coroutines is really easy, and it's so easy that it's so easy and intuitive that you might not even realize that like it's an advantage. But okay, let's get started right away. So I'll be showing you how to start up a Kotlin coroutine. And to start up a Kotlin coroutine, we actually start off with what's called a life cycle scope. So like I said, Kotlin coroutines are lifecycle aware. So in order to start up a coroutine, we actually need to start with the lifecycle that it's aware of. So this lifecycle scope actually comes from the main activity. By using this, if the main activity is stopped or dies, the coroutine will also be stopped. So from lifecycle scope, we will launch a coroutine. Hopefully everyone can see what I'm typing, but we will launch a coroutine. And just by doing that, we have successfully, need to import it. Alt enter for me, option enter if you're on Mac. But just like that, we have started up a coroutine. Everything in this Lambda block will be run as a separate task, a coroutine task, basically. And what stuff should we run? I'll keep it simple for now. Let's fetch the data and save it in a variable. And once it's finished fetching, we will use the data to get the adapter, to make the adapter. Okay. And we just need to call get data here now. And this looks good. So this coroutine will launch and run this block of code, and it's going to be lifecycle aware of the main activity. So let's run it and see the fruits of our labor. And actually, even before it's finished running, I'm going to spoil it. It's actually going to be exactly the same as before, because the final step to a coroutine is to specify where that coroutine should run. And in Kotlin, this is also really easy. All we have to do is just specify where it should be dispatched to with a dispatcher. So we're going to get the dispatcher class, and there's 3 defined dispatches for us to use. The main is pretty simple. This just gets this. This is the default option. If it's dispatched to main, it just gets dispatched back onto the main thread, which is what was happening before. It just basically creates a task and puts it exactly where it would have been in the first place. So not much of a point for us to do main here. The one we really care about is I/O. And I/O means input output. If we specify I/O, then the task will be dispatched to a thread that's in the background that's specialized for input output operations. And that's what we want to do in this case, actually. But let's talk about the last one before we continue, which is default. This is kind of like the catch-all for everything else. So something you want to run on the background, but that's not an input-output task. So things like sorting a very, very large list, for example, might be default. But honestly, from my experience, I've only ever seen main and I/O being used. And that's what we're going to be using today. We want to launch a coroutine that runs this code onto a thread that's specialized for input-output commands. So let's run that now. And even before it finishes, I'm going to follow it again. It's actually going to crash this time. And the reason for that is because views in Android can only be handled by the main thread. It cannot be handled by a background thread or an idle thread like this. And that really makes a lot of sense because, think about if you're a view and you're all of a sudden getting changed by multiple threads at the same time. Like what's going to happen if one thread modifies your adapter and the other thread replaces it? That's kind of bad design. And like the main Android SDK actually isn't handled for that. So we actually need to reassign this task back to the main thread. If you search this up online, there's a lot of ways to do it. So no worries if you don't understand what I'm doing, but there's a lot of ways to do this. So just look up the way you prefer. The way I prefer is this. So I'm going to post this line of code. I'm going to post it as if the recycler view is doing it. It's much more complicated what's going on here, but I'll be explaining this further. I'll be explaining this more further down in the workshop. But okay, now that I made this change, everything should be ready to go. So just to summarize, if you're making a change to an actual view item, that needs to be done on the main thread. It has to be done on the main thread and not on an IO thread. You can just think of this .post as reassigning it back onto the main thread for now. Okay, but yeah, if you watched, now the timer shows up right away. So right from 0, 1, 2, 3, 4, and on the 5th second, then this stuff runs and shows up the list. Okay, so pretty good so far. We already made a lot of headway. We're making use of more than one thread already, but there's something I really don't like about this code actually, and that's this get data function shouldn't really have to worry about the recycler view at all actually. Think about it this way. What if someone else in the code wants to use this data as well? It'd be kind of a shame since we can't reuse this get data block since it touches the recycler view. We ideally want this get data to be usable anywhere in the application, not just for this one recycler view. And the way we accomplish that is actually using live data. Okay, what a live data is it's basically a wrapper for any kind of data you might want, and the live data wrapper will add a lot of ways. And the live data wrapper will basically add a lot of functions that will let us observe for changes in the actual data. And that's exactly what we want here. So we want to fetch the data, but we only want to use it once it's ready. So let's get started with that. I guess we need to replace this. So I guess first of all, we need to declare that this get data function will now return live data. Oh, not this data, live data. Live data, and here is where we specify what the live data should actually be wrapping. So it seems like this is a list of list entries. So let's do that. It's going to be wrapping a list of lists entries. Okay. And let's see. Let's have the function block first of all create results live data, and this live data needs to be a mutable live data. A mutable live data just means a live data that we can change the value of, and it's probably the one you're going to be using too if you're going to be working with live datas. But anyways, let's move on. So the mutable live data, again, we need to re-specify that it's going to be wrapping a list of list entries. I'm just going to copy and paste that. And yeah, okay, that should be good. And we're going to return it at the end. But what should we do in the middle then? Oops, not res. Just like before, we should start up a coroutine using the lifecycle scope. We're going to launch a coroutine and dispatch it to an IO thread. And the code we want it to run, again, is to fetch the data. And once that data is ready, we're going to post that result to the result live data. So kind of tell the live data object that the result is ready. So we're going to post the value of data. Okay, so now our get data is ready. Let's actually use the live data result that's returned here. So in order to use it, we need to observe it. And in order to observe it, actually, the first thing we need is also a lifecycle owner. So just like coroutines, live data and observing are also lifecycle aware. So if the activity dies, we obviously don't want to observe it anymore. And that's why we're passing this in. By passing this in, we know to only observe as long as this is alive, this activity is alive. Okay, and the other thing we need is an observer. I'm doing this right. Appears to be having issues. I might have messed up the file up, but it's okay. I have the backup ready anyway, so this gonna work. Yeah, it's gonna complain about some stuff. Anyways, I'm just gonna revert this and show the final results. Okay. Yeah, same thing as I had before, but I guess I messed up something to do in the import section. But anyways, yeah, same thing I had before. We're gonna observe it. We're basically gonna watch to see if the data changes, and when the data changes, it's gonna run this block of code. So with the new data, we're gonna take it and use it to make the recycle view adapter. All right, so obviously this is already much better in my opinion. By using live data, now we can use this get data function wherever this data is needed. And all we need to do is just write a new observe function. Okay, so this is already much better, but there's actually one more way we can use live data and coroutines, and this is by far my favorite way, and probably going to be your favorite way too, since it's so easy to use. There's actually a way to create a live data, create a coroutine, and run that coroutine and post the live data results all in one step. And that step is actually through a class called live data with a lowercase l. Not live data, live data. Yeah, live data with a lowercase l. Terrible name, but really handy class. It only accepts a dispatcher and a lambda, and this dispatcher will specify what thread the coroutine will run on, and this lambda is going to be what's run in the coroutine. So just by using this one class, it creates a live data and a coroutine all in one step. So what should we have the coroutine run? Pretty simple, just from before, we're gonna get the data and we're gonna post that. But actually in this live data case, we use emits to post values. So we're gonna emit the final data. And just like that, using this one class, we have accomplished the exact same thing as before. We create a live data and a coroutine and run the coroutine and emit the final result. So as you can probably see from here on the 5th second, yep, just like that. Exactly the same, but so much easier to write. And I think it's really intuitive as well. Okay. So let me talk about, yes, the final thing for today, which is going to be making multiple calls. So let's say now, instead of just one data source we need to fetch from, we're actually doing two. So data 2 equals fetch data slug. We're just need the same call. And then let's return both of them at the same time. So hypothetically, we're making two fetches, but it should still be completable in 5 seconds if each of these fetches get their own thread. But that's not what's actually going to happen here, because even though this is in a coroutine, this coroutine itself is still run concurrently. Sorry, in series. So it's going to do this fetch, wait for it to finish before it starts on this fetch, and that's why it takes 10 whole seconds to complete that fetch here. And there's a much better way to do this, and that's by creating a coroutine for each of these fetches. So let's do that. Like before, to create a coroutine, we need to use the lifecycle scope. But this time, instead of launching a coroutine, we're actually going to start one another way, called async. And the difference between launch and async is launch you can think of as kind of like a general purpose coroutine that you can use for basically anything, whereas async is specifically for when you want to calculate out a value, and in this case we want to calculate out the results, like the list of list entries. So perfectly fine to use async. Like before, we just specify where it's dispatched to, so dispatch to IO, and I'm just going to copy and paste this for data too. So yeah, now we're creating a new coroutine using async for each of these fetches. And to what async actually returns is what's called a promise. So like I said, async is for calculating out a value. It's basically going to say, okay, I'm going to get started calculating out that value. I'm going to give you a promise, and I promise that data will be ready eventually. It's not quite ready yet, but when it is ready, I'll put it in the same place as the promise. So we have the promise now. All we need to do is await the results. So we use the await function to wait on the actual the async coroutine to finish calculating out. And if I run it, now because we're launching two different coroutines for each of these fetches, we should see that now it only takes 5 seconds to complete these two fetches instead of the 10. And yep, on the 5th second, we can see all 6 of the results show up at the same time. All right. Yeah, hopefully that made sense. There's a lot of other ways to do this as well, other than async. You can totally do this with launch as well, using a little function called join. You can look that up if you're interested. And if you want to combine data in more interested and complicated ways, there's also a thing called mediator live data, which is capable of combining live data in very complicated ways. But those two are both beyond the scope of this workshop, so I'll leave that as an exercise to the viewer. I am also going to leave as an exercise to the viewer on how to actually make API calls. I know that making coroutines is only kind of useful if you have a large amount of work to do in the first place. And that's usually in the case of making like web calls and API calls. But unfortunately, showing you guys how to do that is also outside of the scope for this course today. If you are interested, however, I do recommend these two libraries, Retrofit and Volley. They're both very good for making API calls, and go look those up if you're interested. Retrofit is by Square, and I believe Volley is by Google. So they're both very well documented. Correct me, Kian, if I'm wrong on the Google part. But anyways, okay, I guess let's move on. We've completed the most complicated section of this workshop, which is definitely the coroutine section. Hopefully by now you're comfortable at least with kind of understanding why threads are important in Android, how we use them, and how we can make the most out of them. But okay, let's move on. This is kind of like a little bonus topic, something you only get from experience, and something I'm happy to share with you guys. The actual problem isn't what I want you guys to focus on. It's more of a philosophical advice for working with Android and mobile in general. So what I have here is kind of a simple function. The layout for the function is fairly simple. It's just like the one text view. And when I create the screen, I'm going to set the text view's text to something else. So long response long here. And what I'm going to do is I'm going to measure the width of the screen. And I'm going to measure the width of the text view, which is showing long response long. And I'm going to show in the second text view what percentage of the screen is being used up by the first text view. So it doesn't sound too complicated. It should be fairly simple, right? So let's launch it right away and see what the app does. So we can see long response long is here, and it looks like it's about maybe 30% of the screen. But if we look at the second text view, it's saying it's 0% for some reason. And that's definitely a bug. It shouldn't be doing that. So why is that? Is there no way to fix this? Now it's saying the correct amount now, like around 30%. What's going on? And I'll spill the beans right away. What's actually going on is, even though we set the text of the text view here, it hasn't actually drawn it on the actual UI yet at this point. So actually, let me do that. Let me run a debug run. And what's going to happen is you're going to notice this line gets triggered first, but you're going to notice that nothing's on the screen yet. And that's essentially what's going on. When we're trying to measure the view, the Android operating system hasn't actually gone around to actually drawing out the text view yet. It simply isn't ready, and that's why when you try to get the measured view, it just returns 0. So that's kind of my lesson to you guys today. As you're writing code, it might be easy to just kind of think of everything you're writing as happening instantly, and you have all the say in the world with what's going on the screen. But you do need to remember that you're still going through the Android OS and the Android SDK. Even when you've requested a change to be done, you can't expect that to be completed right away in every aspect. You know, it's up to the Android operating system when it actually gets around to drawing the correct view out and assigning a width to it. That's why this code doesn't work. It's just the width simply isn't ready for when we get to it. So this solution to that is really simple, and honestly not even the focus of this section. But to solve it, what I like to do is result view, result view. Sorry, not result view, text view dot post. The same post from before. And I'll be explaining what this does. Basically, the text view probably has some tasks assigned to it right now. And then one of those is almost certainly the task to get drawn onto the screen. When I do post, it will post this lambda block, this block of code, onto the end of the text view's tasks. So by doing this, we're ensuring that our code will run after everything to do with the text view has been completed. So after it's actually been drawn on the screen. One word of caution is that if you look up this issue on the internet, you're probably gonna get results on Stack Overflow having to do with what's called a view tree observer. I heavily warn you against using a view tree observer, as it is not as reliable or easy to use as this method. But okay, as you can see now by using .post, this whole thing shows up right on the first launch. But yeah, the point of this section really is just to remind you guys that you are still going through the Android operating system, and you need to remember that. And as sometimes the Android operating system is going to do things you're not going to expect. All right. So that wraps up that little mini session. Thank you all for being here. I know this session is a bit more advanced and probably only attracted like the super diehard Android fans, but honestly, hopefully, I really hope all of you learned something from this and you can use it to take your Android development a step further. Good luck on the hackathon, and if you're doing an Android project, then I hope to see your project and good luck on whatever you make. But yeah, that wraps up this section. If you have any questions to do with me, then feel free to ask. I can answer anything to do with Android, or I guess even CS and like career in general. And yeah, feel free to reach out to me on LinkedIn as well, as some of you have already done. What's the difference between coroutines and features? I actually haven't read up on features yet. Let me take a look. Maybe if Kian has any experience with that, but personally, I don't have experience with features, just because from what I've experienced in the industry, coroutines is what's most like used 99%. Like from all my experience, coroutines is what's used for concurrency and asynchronous programming. I guess from the name, I can guess that RX. Is it RX? But yeah, from reading it, it seems like futures, from a really quick glance, it seems like futures are very similar to coroutine asyncs. So you're kind of expected to get a value from it specifically. But I guess the main difference then is kind of the depth of support for coroutines, since it is a native like Kotlin feature. I I'm gonna guess there's probably a lot more flexibility in the things you can do with coroutines. But yeah, this bookshop is mostly focused on like the application and like things you can do right away to get coroutines working for you. I wish I could teach you more about kind of like the background stuff and like what all the design principles of like coroutines actually are. But yeah, unfortunately, I don't think I even have I don't think I have the experience to talk about that. Good question though. But honestly, I don't think it matters which tool you use to accomplish your goal. Like if you're more comfortable with features over coroutines and you can make it work for you, then like, there's no issue with that. Yeah. Personally, I think from like the bit of reading I did, feature does seem pretty promising. It definitely is better than what Android asynchronous tasks used to be back in the Java days, though. So, but yeah, whatever one you're more comfortable with, just go with that. But no harm in learning the other way as well. So, oh, that's not what it is. Have you guys experimented with iOS? I personally have not, but I have a lot of coworkers, Android-specific coworkers, who have dabbled in iOS before, and from what I've seen, they didn't seem to have problems with the transition. So, if you want to experiment with iOS and you're an experienced Android developer, you're definitely in like a good position to do both, kind of. Yeah, personally, I don't like iOS because you need an iOS device to do it in, and if you want to publish it, you need to pay $100 a year for the developer pass. Might be less if you're a student, but still kind of a bum deal in my opinion. All right, I think that wraps it up for this section then. If you have any other questions, then feel free to just not Slack, message me on Discord. You can ask in the mobile chat or just DM me directly if you want to. But I'll be active on there for the next probably half an hour. So take care.